What's up guys, James here. Today I'm going to be talking to you guys about the abstract classes and interfaces, special use cases for them. Now, to be completely honest with you, I haven't used abstract classes or interfaces since AP Comp Sci, and that was because my teachers forced us to do a project. Not throwing any shade, but that project I did not like. Now, let's start with the interface because those are kind of more easier to understand. You see, an interface is a reference type. It's similar to a class, but doesn't get instantiated like a class. A class implements it, if that makes sense, and therefore gets all of its abstract methods. Along with abstract methods, an interface may also contain constants, default methods, static methods, and nested types. Can also include method bodies, only for default methods and static methods. So writing an interface is very similar to writing a class. In fact, I'd say they're sisters. They really have one key difference, and that's classes describe the attributes and behaviors. However, the interface only describes behaviors that the class implements. So unless the class that implements the interface is abstract, all the methods of that interface have to be defined inside that class. So here is how classes and interfaces kind of differ. In fact, they differ a lot in this case. You see, you cannot instantiate an interface. An interface does not contain any constructors whatsoever. All methods in the interface are abstract, unlike abstract classes that are both abstract and non-abstract. Interface cannot contain instant fields. The fields that can appear in the interface must be declared both static and final. So for your Swift people, it's a constant or a let. Interface is not extended by a class. It is only implemented by a class. Interface can extend multiple interfaces, unlike an abstract class that cannot. So to create an interface, you have to declare it as an interface. In the file, you have to do public interface name of file. So let's get rid of this because we don't need it at all. Okay, so I'm going to give you guys a quick use case or a quick example of how we use interfaces. Now, let's change my class to cat, because cats are fuzzy, and I love them better than dogs, by far. Yes, I said it. Cats are better. Okay, so to create an interface, we got to type in the keyword interface, right? And let's see, cat's an animal and a human's an animal. Okay, so animal. I believe I spelled that right. Okay, so we got public void. Now we all share eat because we need eat, and then we all share sleeping because we like to sleep. Humans and cats? Yes. Okay, so as you guys can tell, we set up our interface. Now to use it, we gotta, after the cat, after the class name, we type implements. I'll just copy paste it. Implements animal. Now this is case sensitive because of course it is a class. So first things first. Since an interface is basically a class, we still have to give it its capital A. And then, it's case sensitive, so we have to do that. It won't yell at you if you were to create a class with a lowercase. It's just how you should set it up, because every programmer does a capital A. Yes, we are weird like that. Now, it's going to yell at me because it's not an abstract method. None of these are abstract methods. So we will have to put them inside of here. So, like I said, we will have to create our little stubs for it. So, public void eat, and then public void sleep, and then now it should be satisfied. Exactly, it should be satisfied. Now, if you guys looked at my other video of how to create a table view, you will see how the UI table view is an interface of the table and how it will require this. It's basically the same way for you people that code in Swift. Yes. And so let's just put, because we're going to call these things in a second, let's do system out.print. Now let's do L1. Can't forget our semicolons. So system out.print cat do be sleepy dough. And then we'll do the same thing, but we do hungry dough. Oops. Hungry. So we have our interface, and like we said, cat implements animal. And so now that these stubs are now that the protocol stubs are satisfied, we will go into the main, and I guess we can do cat c is equal to new instant. So we gotta instantiate it. Cat. I can't forget your semicolon. I think I set this up right. Let's see. Yes, I did. Okay, so we do c.eat and c.sleep. Boom. And it should. Oops. I made that. I did not forget. I promise this. You did not see this. I promise. And there we go. Catty. Oh my gosh. I'm sorry, folks. Catty do be hungry. Do. Put James. I'm sorry, folks. That's embarrassing. There we go. Cat do be hungry. Cat do be sleepy. So that is how you basically set up and use an interface in the most basic way possible. Let's do something for you programmers. Let's do public sports, and this is so. What I'm gonna do here. Sorry. We got its interface. So what we're gonna do here is we're gonna be extending interfaces. So essentially, an interface can extend another interface in the same way that a class can extend another class. You see, we have to still use the same keyword as if we were to extend a class. So we have to use extend, and yeah, that's basically it. So again, and the child interface inherits the methods of the parent interface, just like the classes. Okay, so let's do interface sports, and then we could just do public. There we go. And then we could just do set team. Oh my gosh. My bad. Oh wait, no, that's gonna be string. Sorry, my bad. Oh my gosh. My Swift is coming to kill me. So home team is gonna take a string, and then I guess we can do. I guess that's it. No, we should do public void fan count. I guess that. Sorry, set fan count. There we go. And this one will take an int. Alright. Integer. Integer. Huh, I don't know how to spell integer. Oh wait, sorry, it's just that. Sorry, my bad. And then we'll just do count, I guess. We could just name it count. So here we go. So we set up the most basic things of sports. You have to set the home team, and you have to have the fan count, because what's the point of having a team if you don't have any fans? Okay, so we got public interface, and let's do football, because who doesn't love football? Come on. This is America. And then, again, we have to use the extends keyword, because it's basically a class, but dulled down. And then we'll extend it to sports. Now, just like a class with another class, this will inherit everything in here. So when you compile it, you won't get yelled at for it. So we would do public So football, let's see. We could do home team score. Guess we could do home team scored. And we can set this to an N, and we can do I guess points. Yeah, why not? Points. And then we can do you know what? We can do public mascot. I spelled this wrong. Now we just do public. Sorry, I forgot the void keyword. We need the void because it's dark. So we could just do quarter. There we go. We could just do quarter. Of course, it's gonna be an int and quarter. And I think that's all we should do. And then let's do the same thing with and so and let's do another sport. We'll do this one with soccer. I don't know much about soccer, so excuse me for being dumb with soccer, because I don't play soccer. I don't like soccer. Okay, so like I said, public soccer extends sport, and then public. Sorry, we gotta make this interface. I think this one we should make public too. There you go. Public interface sports, and then public interface soccer extends sports. And basically, we could just do the same thing as this. But I believe soccer has this thing called overtime, and so we could just do this, copy this, paste it in here, and we could just do public void overtime. And then double minutes. Okay. So, as you guys could tell, the soccer interface has two methods, but inherits two from sports. So yeah. So essentially, soccer inherits four methods. Alrighty. So yeah, that's pretty much it with interfaces. So I think it's about time we move on to the wonderful thing called abstract classes. So to create an abstract class, all you gotta do is seriously say abstract class, name of class, and then put in your abstract and not abstract methods. Class is this. I'll just write it out. So we need this. So let's get rid of the stuff inside of this, and let's rename the class dog, because my dog is right next to me, because why not? So we name this dog, and we will have this as public, no sorry, that's not how you do it. It's abstract class animal. Here we go. And I guess every animal makes a sound, and so a dog makes a sound, and so we could just do public public abstract void, and then I guess sound, because why not? Public abstract sound. And so inside of here, we will just extend it like we do extending interfaces and classes. So we do extends animal, and as you guys will tell, I spelled something as you guys can tell, it will yell at me if, like, same thing with the interface, it will yell at me if I don't put anything in here, inside of here, or reference anything in here. So I will have to make a method like this. So public void sound. Public void sound, and then it won't yell at me anymore. So let's just do, because dogs go woof, cat goes meow. System. And then we could just create or instantiate our class. So t is equal to new dog. D dot and it should say woof. Now, let's have some fun here, because honestly, programming shouldn't be this dang boring. So, let's make a for loop. For int I is equal to 0. Actually, let's just do a for each loop. For each. Watch this, guys. This is how you research. Sorry. Oops. Swear. For each. There we go. I'm sorry. We gotta use Stack Overflow. Stack Overflow works way better. Oh, okay, never mind. This is not a good idea. Okay, so what just do for fun fact, you learn more Googling than you would anywhere else. For int I is equal to 0. I is, as long as I is less than or equal to, we'll just do 1000. And then we also have to numerate it. I plus plus. Execute. Woof, 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 woof. Yay. This is fun. So yeah, guys, that is how you guys use an abstract class interface. Ignore this, honestly. To be completely honest, though, here's a quick tip. If you have an issue, and I'm not kidding, research it. Even though it may be stupid, research it. You have no idea how much you actually learn from reading other people's code, because honestly, that's how you learn it. You reading other people's codes and actually understanding it. You see, one of the best things I realized is if you take the time and look through the logics of someone's code, everything is better. You'd understand it more and you become more of a better programmer, so to speak. Also, one thing to also keep in mind, don't recreate the wheel. If someone already has something online, best take it, because as you get older, or as you go down this career of programming, you're gonna want to do it faster. So if you, for instance, say if you want to create say if you're using JavaFX and you want to make sparkly UI, you research it. Don't know. So, thank you guys for watching. Please like and subscribe. And if you have any questions, please don't hesitate to put them in the comment sections. This is James from Duck Software, and I am